So welcome to 602. First thing to do would be please put your mobile devices to silent, and also you do not need any computer or anything because all of this is in our online learning environment. A lot of you are not familiar with it. It's called Learn, and it's learn.library.az. That's where all of the presentation material is present, and also that's where you have to submit your assignments. So all the assignments are in there. So you can just submit all your things online. So the idea was to close all laptops.
That's how I take notes.
Yeah, you don't need that.
Still prefer to. That's okay with you. Like you just said,
Piece of paper?
library, and then I would take notes, like one of them, write it down.
Right.
Yeah.
Piece of paper?
No. No.
Maybe piece of paper.
It is back at this. It is back at this.
Okay.
Yeah. Alright.
And the main reason is that these days we are kind of become, too obsessed with looking at screens and not each other, and also.
Yes. Thank you.
Okay, cool. So, right. So what we're going to do in 602. 602 consists out of two components, which is a design component, which is very much a visual design component, and a user studies component. So the user studies component will be the first day. Today will be the design. And the goal of this is to introduce you to typography and visual design. This is not science. This is more really a craftsmanship. And because of that, there is no truth here. So there is no truly good poster or truly ungood poster. These are all things that are to some degree or to a considerable degree subjective. So don't expect science. Science will be in the user study part. Because it's not a science, there's no textbook that you can look up where it's written in there how it's done, right? So the only way to learn it is to do it. You actually have to sit down and design things, and when you do it, you get better at it. And the main method of getting feedback on, is what I've created any good now, is something called critique. And that is that we put our work up, and then we talk about it. And this would be usually in a friendly and constructive way. But the best feedback you can get is always 50% good and 50% bad. But you get the most information out of it. We are going to have today, especially because we don't really have a task, but every week there will be a task for you to complete. And the idea is to have this all wrapped up by Friday, because I want you to have a good weekend, and I don't want you to bother or having to bother about this on the weekend. So the idea is have everything turned in by Friday, 5 o'clock, leave the office and be happy. Normally we would start with a review. So on Monday when we meet, the first thing to do is to talk about the tasks that you've completed. But since there wasn't a task yet, we skipped that part. When you submit your work, please do me a favor and do last name _ task number, because that makes it much easier for me to figure out who's doing what, because I was interested in download all the PDFs from the website, and this just makes my life slightly easier. Again, this presentation itself is on Learn, so you don't have to, write this down because it is all in Learn. There are also deadlines with all the tasks. And again, the main purpose here is to not draw this out. So the idea is that you really get something done every week. I don't want you to have, postpone everything until the very last week and then you hand everything in. That is a very bad way of managing your time. So every week, and there's a deadline. The learn is an interesting environment. It works most of the times, but sometimes it can also be confusing. I mean, those people who are in category probably know learn. It's a handful. I make mistakes, so it is possible that I screwed up the deadline, or that I missed something, or I make just mistakes. If you come across something that looks utterly implausible or impossible, then please let me know. One of the major problems is that, for example, all the task deadlines have to be entered manually every semester, and the schedule changes every semester. So I try to get it as good as possible, but I also know myself that I make mistakes. So if there's something completely utterly wrong or just something that doesn't make sense, please let me know, and then I'll fix it. Okay? Good. So that was the monologue. Now let's do dialogue. And this is, I guess, something we all have to get used to, but I hope you probably catch on. So I don't think that standing in front of a group of people and just holding a monologue is a good way of teaching. So therefore, we're going to have a dialogue. And my main task is to ask you questions, and hopefully you get some answers. Okay, so we start very small. If you make a visual design, probably using your computer, there are usually two different types of graphical objects that you have on the screen. Can you imagine what they are?
Windows.
Sorry? Windows. Yes, there are windows on your screen, yes. But if you, let's say, pixels, what is a pixel? Small light. Interesting. Can you elaborate? So who knows what is a pixel?
The smallest unit in the screen is quite a square part of the window. For example, the window has 10,000 multiplied 10,000. There means there's 10,000 in the column, 10,000 is on the row.
Okay. So pixel is something on the screen.
Yeah, smallest unit. There's the sensor, like the CCD, or CMOS sensor in the screen.
So there are sensors and there are displays, which both seem to have pixels.
Yeah.
Okay. Now, how many pixels are probably on there?
1080.
Which stands for?
1920 by 1080 pixels.
Right.
So 1920 across, 1080 vertically.
Okay. Right. So let's get close to the television. Let's have a look. Come on. Let's have a look at the pixel. What does a pixel look like? I mean, I know what it looks like, so you tell me, what does a pixel look like?
It's a cell of red with green.
Aha.
Yes.
So,
Bright dot.
right, yes, okay.
Oh, once it's bright, it's dead.
So, one pixel consists of,
Square.
It doesn't need to be square.
so is it square or is it not square?
It's kind of rectangle. It depends on the screen, I guess.
So not
LCD, OLED, or Pentax, I don't know the different technology, different shapes.
Yeah.
But they are just like one
spread out.
small dot, and it's always a unified color. So this
And you
is color
see-
was equal. So
There's three different colors: red, green, blue. That make them hang on the actual string. Yeah.
Well, I mean, that depends, right? For example, now we've got the nanopixel technology for televisions,
It makes them
and then we've got cameras which have different type of sensors which are arranged not just in square boxes next to each other, but they are arranged in all different ways. Okay, so but for this particular one, so can we assume it's a square?
Yeah.
Okay, well, for LCD that's the case, but again, since every pixel has to come out, has essentially it's the sum of three colors, red, green, blue. Every pixel, every square is divided into three. No, please don't. So that's a pixel. That's how things are displayed on the screen and recognized in cameras. Well, what other type of way of storing graphical elements do you have?
You need a graphics card with memory and processing power, or the CPU.
No, it's more like these are all this hardware, right?
Obviously,
It's more about the how do you represent a graphical object?
Name.
You can use a vector.
The vector. What is the vector?
Good question. It's more, it's kind of like a pixel. A pixel has fixed resolution, while a vector can be infinitely scaled without losing the quality. It's kind of, it gets somehow rendered, so it stays, it stays sharp on the edges.
it's mathematical.
Yes.
Basically, it's just mathematical says from here to here, it's this, and so it'll always draw that. And so there's vector graphics, and then there's raster graphics. Raster graphics is like, you know, good old photo, and there's no algorithms behind it to, when you blow it up, you will eventually get to the size of the pixels on the screen, and that you'll lose fidelity and quality of the actual image. Whereas the raster graphics, whatever it is, yeah, doesn't lose that quality as you zoom in, zoom out, or make changes.
That's kind of sums it up. So if we want to represent a circle, we can either do it in a mathematical way. We could say this is the center of the circle and it's a radius of something. Right? It's a mathematical representation. Or you represent this in the form of a bitmap, which means that you have a pixel, and each pixel is represented with a number, which in this particular case indicates the darkness of that particular pixel. But you used a very interesting term there, resolution. What is that?
Well, because it's made of dots that just say dot here, you know, at like, you know, A1 there's a dot, it's black. At A2 there's a dot, it's black. You know, eventually you actually, some of this is just it's the resolution, that's the pixels that make up the dot full image, and if you zoom in on it, you lose that.
Resolution is like the total number of the pixels you use to present a graphic.
It doesn't really scale well.
So,
Trying to inflate it.
so what's the resolution of that screen?
That one, but the actual TV, the 1080, yeah.
So surprisingly, that is utterly wrong.
Okay.
It is not the resolution.
That's how many pixels it has.
Yes.
Yeah.
So the total number of pixels is 1920 by 1080.
Yeah.
But that's not the resolution.
Okay, good question.
It's misleading.
Yes.
So the term to represent the total number of pixels is often referred to as resolution.
Okay.
But that's just not the case. Well, do you use the term resolution in any kind of other context?
Scaling. Like just in water digit.
Ah, right, yeah. So you have, if you have a cup of tea, right, there's a certain number of particles of tea in the water, right? And that would then be referred to as a concentration. Right? So hopefully enough caffeine concentration in here to keep me awake. So that is a similar concept. So if concentration is it for water for a cup of tea, what is it for the screen?
So the density of something.
Density, yes. Density of pixels, yes. So pixels is then equivalent to the caffeine here. So what is the water?
I was saying DPI,
Ah, what is DPI?
dots per inch.
Ah, what's the dot?
well, this screen is 1080 and that screen is 1080. The only difference is this is 5 inches and that's 55.
Okay, so
So the DPI is a lot more on this.
And the
Dots
dots,
per inch.
sorry,
are the dots pixels, or is that something else?
that's a very good question. So who knows what a dot is?
It's a pixel usually.
Usually.
Well, it's either a bigger one.
It's like,
Okay, all right. I'll challenge you. Let's take, let's say, the word, and we say it's 10 points. How high would it be?
It depends on the PPI points.
Well, you said it's 10 points. What do you mean by 10 points?
Yeah, what is the point?
Yeah, you said 10
That's the
points.
moral.
You just said 4 points.
Let's go to the points.
Okay.
With the font size is 10.
Yes.
Okay.
So you.
Yeah.
So so first of all, to get rid of that question, what is the size of the pixel?
It depends on the actual screen.
Exactly.
And it depends on the actual manufacturer. Like this one has a lot more dots close to each other and they're a lot smaller than that one.
Okay. So that's a good news for us. That's saying it's true. A pixel has no size. Well, that depends. I mean, it depends on if you talk about pixel in terms of display, it means essentially, well, the size of the RGB LED in there together, that size. But a pixel in a computer, in terms of, could be any size. It all depends on how you put out what the output is. But we were coming back to the question of resolution. So what does resolution refer to?
Is that the concentration of pixels?
Yes, it is. In dot, what is the dot? So we
Pixels in a unit area.
yes, it is a unit. So we have a couple of terms now, right? We have that is called DPI, right? And out of that we've got something called a dot. We have a pixel, right? And what was the word that you were using right now?
The other dot.
The other dot. Oh, points, yeah. Points, right?
So you mentioned.
So are they the same? Are they the same?
Yeah. In my opinion, I can't speak for everyone else and say what I said, but I'd say they're all the same.
I don't
Dots.
think so.
Yeah.
Dots is like, it sounds like being controlled by the hardware. It's fixed when the display is made. Otherwise, there's no way say like we have 330 DPI on an iPhone. I think that's fixed by the hardware. Pixel comes like controlled by the software. It's like my screen's rendering on Retina, or I can drive that scale to make it down to some other thing. And points is completely defined by the design itself. I think the other equations between the dots is fixed, the pixel is based on that. It's like I use how many dots to display a pixel, and then I use pixel as a unit, say this wall is 10p, it's 10 points, and there's an equation like, I think it's called like pixel per point something.
Pixels per points.
Yeah,
Pixels per points. Oh my goodness. Pixels per point. I never heard that.
maybe I just made it up.
Well,
I always relate DPI to the printer, and the printer's output is measured at DPI.
Okay.
The outcome, whereas in digital output, I would say with a pixel and point. No idea. That's an old term that comes from Roman times.
Yeah.
Well, that's true. So DPI is indeed a very old term, and we'll get to that. But you were talking about density, right? So we have this equivalent to the T, right? Is this density?
Yeah.
Right. So resolution is a measurement of density measured in
Pixels. Or dots.
No. That would be equivalent to saying the concentration of tea in my cup is 0.2 grams. That's not a measurement of concentration.
If it's like some distance and how many pixels are in the.
Exactly. So it's always a number of pixels dot points per a unit of length, right? In this case, inch.
Yeah.
Right? But you can also have PPI, pixels per inch, or point per inch, or points per pixel. But resolution refers to how many dots, pixels, points per unit of length. And inch is, I guess, comes from the US is largely dominating software development, and they are working with inch, the old imperial system, which doesn't make a lot of sense. So, for example, a unit like dots per centimeter would actually make much more sense, but not so good. Now, so if we have this beautiful circle over here, and when we want to turn that circle into that bitmap, how do we do that?
Yes.
Would put on like a sheet of small grids onto that circle.
Yes, a grid. You put a grid over it,
Yeah.
right? And a grid, when the grid is, let's say, predominantly black, you make that pixel black, and if it's not, you make it white, right? And the size of this mesh is what? Is the resolution. Right? Now you can also do the reverse. That means you can also turn a bitmap into a vector, which by a process called tracing, but there's no easy way of explaining that. If you wanted to do that, you would go into Adobe Illustrator and just use the function and just do it. Right. Now, since we have got some experienced designers in the room, some of you might remember the magical number 72 for resolution, 72 dpi. Did you ever encounter that? And how did you encounter it?
It's well, if you make it's like the width of the it's the width of the screen for an old pixel, I guess the number of pixel, yeah, the pixel width for the screen designs that you made for an old iPhone. Now you would multiply that by 2.
So I don't think there was ever an iPhone that had only 72 pixels horizontally or vertically. There's always been more than that.
Yeah,
So what's
I saw before reaching out displays one day.
I remember that on the CRT there were like 600 by 800 or 800 by 600 for the square boxes. So 72 pixels would be small enough to build objects inside them. I have no clue.
Is that the resolution? Is that like the concentration?
Yes, so indeed, it used to be, I mean, if you've been long enough, or if you've been around long enough, then you will remember this. These days, 72 is not so much of an issue anymore, but it used to be like the number for the density or the resolution. Okay, so it was always 72 dpi for screen, right? 300 dpi for print, right?
Okay.
Yeah, don't remember that?
No, I remember little bits of that.
Little bits.
I remember like 300 for the printing, yes. That's like the maximum for do.
Mm.
Was that like the highest concentration that you could get?
No. Well, back at some point in time, yes.
Yeah.
Not now, today, not anymore. No, today we're much higher than that. But so here's the history lesson. Back when printing became digital, it means when people started to make printing using a computer, right? You of course have a problem, namely that you want what you see on this computer screen should be the same as what you see when you print, right? So if let's say I have a document open and let's say 100% magnification, right? Then what you see on the screen should be exactly the same size as what you see when you print it, right?
Okay.
So, and Apple at that time was one of the first companies who did desktop publishing, and they had a very smart idea. And the very smart idea was to indeed have a pixel, so on your screen, be the same as a dot, essentially.
Is it document printer?
Yes.
Before it was printed, yeah.
Yeah.
So,
And printing is old. So the question about how tall, is a 10-point. Actually, no, I should do this. It's this word point. So if you have a 10-point word, the unit point is defined, is much older. It came out of pre-computing times. Right? And this is where the kind of magic comes from, is that in the American systems, there are 70 points in 1 inch, which makes 1 inch, 0.35 millimeters. Right? And if a point is equivalent to a pixel, right, in terms of its size, then what you see in 100% magnification of the screen is equivalent to what you see in the print. Right? And that was Apple's design goal. So they designed screens at that time which had a resolution of 72. Right? So that a point and a pixel is the same. Now, these days, we've gone way beyond that. So, for example, that screen in the back there, it's at least 300 pixels per inch. Right? So, we've gone way beyond that. But that also means that at 100% magnification, what you see on the screen does not have the same size as when you print it. So, coming back to our question, if you have the word word and it's 10 points, so how tall will it be?
3.5 millimeters.
Yes, 3.5 millimeters. So if you ever wondered, if you use typeface 10 point, what does the point mean? 1 point is simply 0.35 millimeter, or 1 inch divided by 72. That's where it comes from. Right. Other units we need to know about is, of course, file sizes. So just be aware of it as bit, byte, kilobyte. Then it gets complicated because either you assume 1024 or you assume 1000 to go on further on. But essentially, it's so much easier if you do it in factors of 10. Then so that's where this uncertainty comes from. So these days, a lot of people just say 1000 bytes is a kilobyte instead of 1024. That's a slight difference. Practically, it has no more practical implications. But then from there on, it's always 1000 to go to the next unit. Interestingly, again, because the software market is largely dominated by American companies, that's why this kind of point came in. But of course, printing again is much, much older than computers. So the Europeans actually had a different type of point, which was called Dido points, which is different. But I guess these days we just got accustomed to the American board. Right. So you said something about 300 being what the maximum you get out of the printer? Who said that?
You did.
No. Yes, I just said it, but before I said
In the
it.
in the 90s or something, yes, 300 DPI is what you would get on your inkjet printer or whatever. That's what it would actually be printing out. And now you can get like photo printers that
Okay. So
it's just finer dots on the page.
alright, so I'm not sure if it's worthwhile, but I could challenge you on that. I could go to Epson or HP or whatever, and I go to a product sheet, and I'm fairly certain that all of them will advertise more than 300.
Yeah, so in the 90s. It's a big thing.
So that was what the advertisement was like in the 90s?
Yeah.
No, there's still some truth to 300, but it has nothing to do with what the printer is being advertised for.
Yeah, photo printers say that they can do a lot more dots on the page to project lifelike images.
So why does it not make sense to send something with a higher than 300 dpi resolution to a printer?
To what? Buffer space? One?
Well, I mean, that's what I like with this file size on there. The problem, of course, is that the more pixels you have, the bigger your image gets, the longer it takes pretty much to do anything, right? So you actually want to be at a level of density of your pixels that is useful for your output, right?
So it just takes longer to print, so stop it.
Yes and no.
Unless you're wanting to actually do a photo, then yeah, sure. That would take as long as you like.
Well, see, I still manage, I'm not sure about you, but when I want to get something printed, it's usually 50-50. Like 50% of the times it just works, and 50% of the time something goes wrong. Particularly if you design something more interesting. If it's not just printing a PDF paper that you download from a paper or something, right? If you do something yourself, things usually go wrong. But there's a reason why it doesn't make sense to have an image with a higher resolution of 300 dpi.
I can't see the difference anymore at some point.
Exactly.
What
So-
does it mean?
So we currently have, if you go to any of the, electronics company like here in New Zealand, you want to buy a television. We used to have full HD like this, and then that was 4K, now we've got the first 8K. Do you think you can see the difference between 4K and full HD?
Yeah.
If?
Depending on how close you sit in.
Exactly.
So the desktop monitor, like, yeah, you want a 4K thing in front of you. Brilliant. Crisp as. This doesn't matter. TV, how far you are away from it.
Exactly. So there is a limitation of what our eyes can actually see, right? And we have a certain, in a way, resolution, and it's usually being expressed in a kind of viewing angle about how much we actually can see. And there's a natural limitation to that. So at a certain point, we will just not be able to tell the difference. So if you have a printing job, usually going above 300 will not result in you being able to see a difference. That's kind of like almost a sad truth to a lot of design, is that once you get trained in it, you see the difference, but all of your target audience doesn't. So, yeah. So what do you think is a good, if you have, let's say, a newspaper, make a guess, what's the resolution of that?
300.
Big ones.
No. So if you buy a glossy magazine, maybe 300. But if you get, say, the daily newspaper or the weekly newspaper, it's not 300. You said me too? Well, that's a good number. Well, here's a couple of resolutions that are quite typical. But before we go there, I need to hide some piece of information from you. So, we have got two printers here at the lab. And one of them is a color printer and one of them is a non-color printer. Right? Let's have the non-color printer. This non-color printer, how many colors do you think it has?
Black.
One, which is black. Okay. So how many colors do you think the color printer can print?
It's either 3 or 6.
Four.
So you got 4, 6, 3. What is it?
By combination, if we go to 155.
Oh, you said how many colors can it
Yeah.
print?
Mhm.
Oh, well,
It should be like
Oh,
255. 65.
Interesting, huh? So, well, in the most constrained definition of this question, the answer would be 4. It can only print 4 colors, which stands for cyan, magenta,
Yellow.
yellow, and black. Okay, but there's no B in there. It's called, usually it's referred to as SMIC, cyan, magenta, yellow, K. It doesn't say black, it says something with K. So what does K stand for? It stands for key. So why would you do that?
would it be to make like more black mixing colors and not forgets? This is a big key color.
Well, there are 2 reasons. One is that if you would have a B in there, it could be confused with RGB, with blue. Right? But you remember in your school days, and you'll say you take all your colors or you take a couple of colors and you mix them all together. What do you get? Yeah? Brown? Yes, that's pretty much the case. Usually you get some sort of dark brown, but not really truly black. Right? And that's why they add key, a black color to it, so that you can get some true black. It also saves a lot of power or ink, because a lot of documents, office documents, when they're just black and white, instead of mixing, the other colors together, and you can just use this one color, which makes it much more efficient.
Pro tip on that one, if you actually just print your stuff to a colored printer, if you don't specify black and white, it might even read it like black swirling thing is like, a little bit of red, green, blue, and then actually print it that way. So if you definitely say black and white, then you print it.
Maybe
black
you
and white.
wanted that, because if you have 100% K, then that's lighter than 100% of every color. So if you have 100% cyan, magenta, yellow, and black, then that's like it's a much brighter, more beautiful. It's a darker black. So
I was saying, yeah,
in some instances.
it's a good saying that, but I was saying it in the case of wasting color.
Well, but the point is, not every black is black, right? So there are different ways of doing black. And one of the biggest problems usually is, let's say you took a photograph, right? And let's say it is of something black, and you want this to be surrounded or embedded into a black surface, and let's say you define that with SMIC, and you just put the K to 100. But your photograph is not in SMIC. Your photograph is usually in So does RGB have black?
No.
So the black in RGB is defined as 255, 255, 255, right? Which is not the same as 100% K, right? And then these two will come together and you will see the difference. And then you see that, yeah, not every black is black. Right. Okay. But, interestingly, there are also still other units out there. So something that you usually, or unless you've been a designer, you usually will not have access to is something called LPI, lines per inch. And that refers to a certain type of printing, which is called offset printing. And we'll get to that a little bit later. But they use yet another measurement of density called lines per inch. But roughly speaking, usually more than 300 doesn't do you any good for print. With screens, we are right now in an interesting, situation where screen resolutions these days, particularly on mobile devices, can be so high that they might even exceed 300. So that gets interesting. Okay, but we're talking about paper. So paper. Now, what is this? A4. What does it stand for?
Standard,
What kind of standard?
ISO standard.
No, it's not ISO.
No ISO?
It's not ISO.
Oh,
And there's one person in this room who knows which standard it is.
I think it's German standard.
Yes, it is.
And I think like somebody at Bauhaus, like, get kind of.
I'm not sure who came up with. No, well, it's a standard. And what is the full title of A4? It's called DIN A4. Or what does DIN stand for?
probably the dude that made it.
Do you know what DIN stands for? It stands for Deutsche Industrienorm, so German industrial norm. Right. So this size you can either blame or cherish the Germans for. Now, so there are two interesting questions about this. A is the easy one. What size is this?
It's like 297 millimeters across by 350 well.
No.
It's not
Or
always
something.
It's 27 something 29.
Yeah.
So what do we have? So we've got. So the short side is.
No. 273. Around that.
271.
Because I was always trying to tell that's how between A4. So
Ah.
I remember that.
Yeah, the Americans get very good. The Americans are the worst in this respect, but let's stay with this system here. Say it again? No? So, the short side is 210, and the long side is 297 millimeters. Okay, that's one interesting aspect of it.
You have to say it's millimeters as well.
Millimeters, yes, actually, you are
Since we're really being able about that.
Right, so.
That's easy.
That's
Sorry.
That's really large.
You know how they
Yes.
Okay, now that's the easy one. But the more interesting question is,
I don't know.
A5.
And what size is this?
No, I don't think it's A5.
102.
That's A5.
That's A5.
210 by.
No, it's
Yeah.
It's hard.
148.5.
Now let's make this a bit more interesting.
try to make it square.
Yeah.
That's it.
Okay. Okay. So, what obviously this is? Okay. If I halve this, what happens? What's the biggest difference?
2 down one side.
Yes, but what's the biggest difference between this system and that system?
You're still getting the same thing, I know.
Ratios.
Oh, yeah.
Ratio.
Yeah, that's it.
The box.
So, what's the ratio? What's the ratio here?
1 to 1.
What's the ratio here? 2 to 1. Okay. Now, what's the ratio here?
Just about 1 to 1.
Okay. And if I halve it, what happens?
Same rate.
The ratio stays the same. Isn't that neat?
So this is the golden ratio.
So, okay, so,
Probably is. Yeah, well, for that one. Oh,
Oh,
look, it is.
so that's the ratio, 1 to the square root of 2. Okay? Now, the biggest size is A0, right? And that has a certain dimension. Let's go back. Oh, it's okay. So, it's 841 by 1189, right? That's A0 is the largest one. Still, the question is, why? Why 841 by 1189? Because that, depending on, you could choose any value here, right? As long as it's in the same proportion, right? And then it will always be halves of it, right? But why 841 by 1189?
Is that like the size that was used in society for some reason? Like, is it related to the smallest one?
No, this was series. It's a series, right? It's always just either multiplied by 2 or half, But if you keep a proportion, if you keep that stable, you could use any absolute value, right? And the reason for the existence of these particular values is not the smallest. No, so it's not A8, it's A1 who was the main driver.
Is this the size of the folder of the newspaper?
No. So, again, this is much older than computers, right? So this was done before computers. So imagine you are a printer, right? And let's say you order paper for your print, and you got a whole stack full of papers of A0, right? And let's say you order 10,000 sheets of A0, and it's being delivered to you. And you want to check, well, did I get 10,000 sheets? What would you do?
I wait.
Wait. That's very smart.
Could we just go,
Check the length,
yeah,
the height of the stack.
That would be another way, but it depends on
Both
the
ways are very.
ways probably better, right? So it's another important component to paper is we're going to know it, is its weight. Okay, let's say you know that again, how would you? Paper. It's not just the weight of a piece of paper. It will always be again the measurement of density, right? You would have grams per something, right? Probably grams per centimeter or grams per square meter or something like this, right? That's how would you define density of the paper, right? Okay. So the beautiful thing is that 841 by 1189 is exactly 1 square meter. So if you know that the weight or the density of the paper, let's say, is 100 grams per square meter, then you can just easily weigh the whole stack, and you know that A0 is 1 square meter. It just makes it so much easier. On the right, you see our friends, the Americans, who still stick to the imperial system. So they don't, unless you're in science, they don't use centimeters and millimeters. So they're they have three sizes: letter, legal, and tabloid, which I put on the right. It's in inch. And when you design something for letter and A4, this is usually the tricky one. So if you download a paper, a scientific paper that was done with letter, it's slightly different. So A4 is slightly taller. So if you want to make a design that's being printed by Americans and the rest of the world, then you need to make sure that your design kind of takes into account both of these.
Can I file any piece of paper more than 8 times? That's a physical thing. You can't.
But see, the interesting thing with the letter, legal, and tabloid is that they don't preserve their proportion, right? So that doesn't work so nice. Another question. We know A4, but there's also B4 and C4. What is that used for?
Never used it, so don't know.
So what is B4 or B5 or B6?
British?
B for British, nice. No, it's as boring as ABC. So no. I bet you all used it. You all used B5 or B6. I'm certain of it.
School.
No. When did you ever see something B5, B6?
Don't even know what it looks like, so.
Letters.
Yeah, with letters. And what letter is it? The envelope. Yes, it's envelopes. So the B series are envelopes. So A fits into B, B fits into C.
Germans are very smart.
We like things to be tidy.
That's why you don't catch the most.
So when it comes to screens, things get complicated these days because there are so many different sizes, proportions, and resolutions that it just gets really, really complicated. So I put like a couple of them on the screen. There's just no really easy way of saying it. It is just what it is. I mean, just if you think about the different proportions that screens have, I mean, so there's no reasoning. It is just what it is. For a designer, it's of course very challenging because if you design something for the screen, then the question is, what screen? Right? Is it like this? Is it like this? Or is it like that? So that's a real challenge. We used to have nice little tools, which I showed on the right. And this shows you how much of a proportion of people on the internet can actually see that web page. So 99% of the users will be able to see this. 90% of the people will be able to see that, and so forth. And it was because Google keeps tabs on a lot of our information, and they just record screen resolution and screen size. Here are some nice acronyms that they use to describe different types of screens. I have not figured out what the system is. Just names and resolutions and sizes. It's not always so clear. I mean, particularly resolution. I mean, usually they don't advertise that so much. Like for that screen, they'll advertise full HD, and they say 55-inch. But then you still have to do the math in your mind to figure out what does it actually mean in terms of resolution. There are some nice tools that you can use where you just put in the number of pixels, put in the diagonal size, and it will spit out essentially all the math for you, which makes it nice and convenient. We talked about paper weight. So here are some weights that we have. Office paper is usually referred to as anything less than 150 grams per square meter. Then then you're saving up with cardboard, pasteboard, different types. And again, the unit of measurement here is grams per square meter. That's the unit. And we have different file formats, bitmaps and vectors. Some use compression, some are uncompressed. So is it a good thing or a bad thing?
Good to save size, not so good on, quality.
So explain.
Explain.
Yes.
So JPEGs are compressed images, raw files are not. Raw files are as you take it out of the camera. It's what everything the sensor captures. JPEG is cutting all the crap you probably won't see out of it, or what make a difference. And grabbing colors that are similar enough and just going, that's one color by compressing it.
Right. So compressing, so there's, so what you said is largely true. JPEG is one of the most common file formats for bitmap images. And it uses a compression algorithm. And this compression algorithm throws away information. And they throw away this information, that is that information that you are unlikely to see. And it became very popular because of the internet, because their transmission of information has direct relation to how long it takes for the page to show up. So there it makes a lot of sense to use compression, because the transfer time is important. But when it's between you and your printer, does it matter?
I think we look at 300.
Well, that's one thing to it, but
I think it does. Because it's compressed, maybe image quality, maybe it's not bright anymore.
Yeah. And maybe like the time that you got about a couple more seconds, make it a bit of quality.
yeah. So here's the misconception: the compression is only for the file itself. Once you do anything with that file, it will just take the same amount of memory. So if you open a JPEG, or you open a PNG, or you open a PSD, whatever, it will all take the same amount of memory of the computer in terms of RAM. It's only when you save it to disk that the compression takes place, right? So, but transmission time between you and your printer probably doesn't really matter so much. So you don't win anything by using JPEG. And it throws away information. Why would you do that? Right? There's no good reason for it. As a matter of fact, what happens if you really want to ruin a picture? What you do is that you open the JPEG, you save it as a JPEG, open it, save it again on a different file as a JPEG, open it, save it again as a JPEG, and what you see is that the quality of the pictures takes the nose off.
It actually does that. Seriously, I didn't think it
Yes.
actually did that. It's just like a photocopy.
Every time you save it, it will compress and will ruin it. So for your workflow, that means if you ever want to compress, you should only do it once, and that only at the very end. Anything you do before, there's no reason to use compression in terms of compression that loses quality. There are compression methods that don't lose quality, but again, they will take the same amount of RAM in your computer. So it's no good reason. So the only good reason to ever use compression is if you want to put something out and it goes out on the internet. Other than that, don't. Right. Then, when it comes to software we use, we by now unfortunately have pretty much a monopoly. It's the Adobe company who's pretty much running the show. They've just bought up all the competitors. So there are still alternatives available, particularly also from the open source area. So there are image editors or photo editors or vector-based programs that are available for free. But if you ever want to get a job in this area, you better be familiar with Adobe products because that's probably what you'll be working with. Now, Adobe recently has moved away from a old school license-based model to a rental model. So these days you can't actually buy Adobe products almost anymore. You always just rent it. They have pretty good deals for students. So they have like a monthly subscription fee, and you pay that, and then you can use all of their products. The University of Canterbury does not have software licenses for students for Adobe. So you are pretty much on your own on that one. But it is pretty affordable, and since it's the industry standard, to my mind, it makes more sense if you get used to Adobe products.
Can I put in a little thing on that?
Sure.
They also have yearly subscription. And also the other thing is, I think there's like a minimum term with the monthly subscription for a year. And they're real pricks as well. So when that year comes around, if you haven't within 14 days said, no, I'd like to cancel, they'll subscribe you for another year automatically, and you can't get out of it. You have to pay 50% to get out of it. So they are a brilliant company who really gives a damn.
Yeah. Well, their move to rental software has been considered by many as well. I think it's not a good idea. People might disagree. But then again, if you have the option, a license for Adobe Photoshop used to cost more than $1,000, right? If you have that versus like $10 a month, and you can use all the products, that seems like a good idea. Again, since you're a student, they also have specific discounts for students, so you should definitely take advantage of that one.
Was it to deal with the piracy issue?
Yeah. They always say that though. And this way they can actually, because it's always online, it's always checking. So yeah, that basically is a theft prevention. So that's what it really is.
But practically speaking, you'll be having access to a computer here, but we cannot provide you with an Adobe license. That has to come from your own pocket. Yes.
Is it okay if we use those?
In principle, yes. However, my main concern is if you want to ever do anything in this industry, then most likely in the future you will have to deal with Adobe products. So it's better to get used to it.
Also, support for the Adobe stuff is really easy. If you want to find anything, how to do anything, it's really easy. And it's the user interface is better than GIMP and a lot of free ones. So I bought it.
But if you get a license, can you use it on different two devices?
And you also get the tablet stuff and also cloud crap storage.
So they offer a lot, but they also cost something. But again, you could essentially limit it if you want to like a 3-month subscription, and then you can stop it if you want to. And that's not going to cost you that much. So it's not really a big deal. It's just something you need to be aware of.
I know I have it on my work computer and hour.
Verifying the student, I did give it a 1 year free subscription.
Just
So the last time I tried was the
generic
Adobe
license.
Did you get
It's almost got
That is-
it.
I know what, I already know the database because
So they have to be
I
like
found
university.
And we have a work from home software licenses.
Yeah, a lot of places that do student discount.
yeah, but in any case, the truth is that University of Canterbury is not providing an Adobe license for you. That's simple as that. So let's get busy. Let's design something. So your first design task, which will be due on Friday, will be to design the logo.
For yourself.
Yeah, so it's a good question. Whenever you design a logo, it is usually for or about something, right? So we've got Puma there, we've got Adidas over here, right? So you'll see them everywhere. But to make this a bit more interesting for you to learn something more about design, I would like you to pick a design classic. So design has been around for a long time, right? And there are certain products and designs that are referred to as classical, that look, when you look at them today, they look just as good as they did whenever they were invented.
Maybe not so much with IBM.
Well, there are certain things which are fall to fashion, and at some point they just become terribly ugly. But certain things are so astonishingly beautiful, and so time can't harm them. Right? They will always be beautiful. So I would like you to pick one of those design classics and make a logo for that specific design.
What do you mean?
Yeah.
Can you give an example of a design concept? Are you talking about a product?
For example, yeah.
So to clarify, you're going to actually pick an existing design and then make another design for it. Is that what you're saying?
Well, so let's take an example. For example, product designers are usually obsessed with lamps. It's one of the things they do, or chairs, a very popular topic, right? And there are certain designs for certain chairs, right? And some of them are really, really famous, right? So if you would take one of those very famous chairs and you make the logo for that chair.
That's
Okay,
for a
so
specific product.
you get a product and you make it. Yeah. Okay. Design.
So
Go for it.
here's an example of a good combination of classical design and a brilliant logo. What is that?
Macron's arches.
No.
Maybe it's a German person.
Of course it is.
Here you go.
It's a Volkswagen Beetle.
Ah,
When they re-released that, when was it, around 2000, right? I mean, the Volkswagen Beetle had been out of production for many years, except in Mexico, and then they came up with a new design, right? And this was the logo for the new design. So that was a pretty brilliant logo.
I guess someone drives speed-ups.
Right? So, create a logo, and you need to do two things. First of all, we need to see, of course, to be able to judge or to put into context your logo design, you need to question. Because it's your choice to choose whatever you want. I don't know. You might pick something that I also don't know. So we need to have a little, you have one page about the actual design concept you picked, and one page for the actual logo design, right? A4 on cardboard, and upload the PDF to Learn. And the cardboard you'll bring with you next week Monday.
Cardboard, sorry.
Mm-hmm.
Where are we going to get cardboard?
it's a cutting somehow.
I know, where do you buy paper?
No, I don't use paper.
Seriously.
Side of the times, huh?
What's some cardboard on there?
So what, we have to make a cardboard logo as well?
No.
So I can put your presentation on
Oh.
A4 cardboard, so you can carry it over here.
So
Okay.
it's like a little display.
Yeah, it's more rigid, so you can just show around, I guess.
Okay, cool.
So how you print it on the cardboard, you can have the paper,
Yeah, just paste it.
stick it on cardboard,
Glue it on.
glue it on.
Well, that's a good question.
I know, leave it to your interpretation.
Oh, you can then.
And you can fail.
So, again, design is learning by doing. So you will do things, and you will make mistakes, obviously, and you will learn from them. And that's the whole point, you learning, right? The question about how do you get something presentable on cardboard is a problem. And there are many different solutions to this. What you should ask yourself is, what is the most beautiful way? How does it look the best? Imagine yourself, you're being tasked by a client and says, oh, I'm going to pay you $500 for logo design. And now, next Monday, you're going to go to the client and you're going to present your design. And you want, of course, it to look splendid. And please do me a favor, because it makes the whole thing much more fun. Please hide the explanation side, not just only from me, but also from all your mates. Because then one of the first things that we do is we're going to do very fast is we're going to try and guess what the product is. That's just fun. So please hide the information about explanation. Don't show it to each other. Makes it more fun. Yes.
What is the design explanation? Is the explanation for the logo or is it
So again, let's take the example of the Vita Beetle. Right. Let's say you picked a product, a design classic that nobody knows, right? Then it's very difficult to judge how good the logo is because you need to provide context, right? I mean, you all have this image of the Volkswagen Beetle in your mind, right? Don't you? It's a very iconic design car, right? And you already have this image in your mind, so you can, oh yeah, that makes sense, right? But if you pick something, a design classic that nobody knows, then it's going to be more challenging. So that's why we need to have this context, right?
So your code is 2 color or 1 color?
2 colors.
You show everyone the logo and they guess, try and guess what it is, and then you show this is what it really is.
So it's like I'm designing a logo for a water bottle, and I'm going to make that, logo so you can instantly guess it. Is that what you really want?
It's not guessing.
See.
It needs to be a good logo for it.
Assuming you're aware of it.
Good. So let's take let's take another example.
Then you get it.
Let's take an example. Another example. Let's take what is this?
Nike.
What does that have to do with Nike?
They branded it.
We always have Nike written on it.
Yes, but the point is, there's no relationship with the word Nike, any of their products, or anything that would justify a swoosh. Right? Here, you have a car which has a certain shape, and this is an abstraction of the shape. Right? With Nike, that's not the case. It's something completely different. So there are different ways of how you can approach logo design. Right? So it doesn't have to be an abstraction of a form, and then I can easily guess it. That's not necessarily the solution.
But it's what you're asking. Basically, you're asking us to guess it.
Again, it's not about optimizing that. It's just a fun task to do. Believe me, it's just fun.
I'm kind of like the children's toys, and I'm going to put a skull bones on it just cause.
Well, if you say go to that evil genius bar, they don't have a sign, they just got a skull and crossbones. So when you have to explain to people what it is, where it is, it's the place where the skull and crossbones, they don't say their name. Don't know why.
Or they're actually brands, for example, like Muji. Their policy is no logo, no brand. Whenever you buy a product off them, it will not say anything about where it's from.
Everything is there.
So the absence of any kind of branding is the branding.
Anonymous.
Because it just has to be different, doesn't it?
Well, marketing is very interesting.
Yeah.
What do we use for the logo design?
That's a good question. What would you use for logo design? And the starting point.
To start.
So I would say printing.
Adobe Illustrator. Okay. Why would you prefer that over, let's say, Adobe Photoshop?
Vector versus raster.
So why would you want to have, what do you want for this task?
Vector.
Why?
Because it's lossless.
Well, you can also have a bit method as lossless.
Well, can blow it up, you can manipulate it, and it doesn't actually lose the quality. Whereas
So what you're talking about is scalability.
or compression.
No, you're talking about, no, not compression, you're talking about scalability. So why is it important for a load to be scalable?
You want to blow it up so you can put it on the front of your building one day.
You know, they're
Depends on just you, yeah, you have many products, maybe bigger or smaller.
Exactly. So a logo is attached to the side of the building as well as to a shoe or something very tiny, right? It needs to be scalable, right? And one of the properties of vector graphic is that it is scalable. And you don't lose any quality if you scale it up, right? That's why, again, but there, of course, as with everything in design, there always be counterexamples. You know, not every logo is vector-based, right? That's just not the case. There are also ones which are vector-based, you know, with a flow graph in it and all sorts of things. So that's why I call it non-scientific. There's no ground truth. There's no right answer. Right? It all depends.
Cool. And marketing markers is better. Right?
Don't worry about your mark. Worry about what you learn.
So we are getting marked in it.
Yes, of course.
Students.
That's the first question. Like, how do I get the highest grade for the least amount of effort?
Yeah.
No, that's not the case. The most interesting question is here: what is the maximum you can learn from this? That's what you should ask yourself. Not what grade you get. Grades will not matter in the long run.
I guess knowing your target audience is always a good thing too.
No, that's another good consideration. All right.
Brilliant.
Good. Let's get going.
So this is by Friday, 5 p.m. PDF file.
Yes.
Then Monday we bring.
Yes.
Cool.